Cool. How's it, everyone? People might be joining while I started, but we're going to start now because it's already a couple of minutes. So we gave enough. I think we got around 30 to 40 people already in. So that's great. So yeah, just to kick off, this tutorial that I'm going to do, or this course today, is going to cover a full stack developer, what we deem as somebody that works on multiple layers of an application. And during this first session or this first course, I'm going to show you how to set up a new project, connect that project to a database, and actually access it from a website using RESTful services. So the course I called is the like button, and the reason why I called it the like button is it's the most easiest use case for everyone to relate to, because everyone knows what a Facebook like button is and what a on YouTube like. So a lot of people see the button, but they're not exactly sure how it works, or they don't understand it. All they know, they push a button, and that returns a like or increases the like on that specific post. I just want to unmute Ben. So just some housekeeping. Benedict is in the chat as well, and he's going to be helping out. So if you'll have any issues seeing my screen or hearing me clearly, just send Ben a message. He'll be able to chat to me directly. So I'm just going to unmute him quickly. Ben?
Hi, everyone. I'll be there
You
to help. Yeah.
So yeah, I muted everyone in the room because obviously a lot of noise will cause a problem and disruption. So if y'all have anything to discuss or any issues on the stream, you can speak to Ben on chat. Cool. Just to kick off, during this session we're not going to have questions. In the end of the session, we will take a few questions. But for now, if you'll have anything, just make notes as we're going through it, because there's a lot of topics that I'm recovering during these slides and during creating of the application. The slide is going to lead up to building the application live. We're going to start from scratch. So as you can see, we're going to build a secure, scalable application from scratch using Spring Boot, Angular, and deploying it with Docker. In this specific lesson, we are going to cover the Spring Boot part of it, not the Docker and Angular. Cool. To kick off, so going on to the first slide, I'm just covering who are we. So what I'm trying to establish and what we're starting with, I have a group of senior developers. Some of them are my friends, and some of them I know from back a few years ago. And what we're trying to do is start off a community that we as senior developers or in tech leads are coming together to share knowledge to assist developers to grow. That is the junior developers, mid developers, even other senior developers that want to understand more on how to become a full stack developer or cover certain topics that they're not familiar with. So we're trying to establish this continuous improvement. And every single week, we're going to try and do a live session with somebody. So it might not be me. It might be somebody else covering a topic that's a different development topic. This course that I'm starting now will have multiple sessions because we can't build everything in one session. But the first lesson is going to show you the base, and we're going to build on the base in the coming weeks. It'll take as long as, I believe this type of course would take 4 to 5 sections to fully complete. But for now, we're going to kick off with the first session, right? Who am I? My name is kuben.thathiah. I am the development manager at Supergroup. I'm involved with Java development for about 16 years now, and I've been doing Spring development and Spring Boot for many, many years. I think Spring Boot from almost when it was introduced, and Spring for a while. So in total, about 16 years Java development experience. And what we're calling this course, or this group of courses that we're building, it's a rapid fire development technology e-learning platform. So all of these courses that we're going to introduce and do more live sessions, specifically here in South Africa, that's our target audience, is going to be this technology e-learning platform, which we're calling rapid fire development. I have a YouTube channel and I have a GitHub account that all the code that I'm going to do in this project and all the code that other members or other seniors that contribute will all be on those GitHub accounts and on one YouTube channel. So the recording that we're doing now, this presentation, it is being recorded and will be uploaded to that YouTube channel. Just to kick off, what is this course about? And I've been covering that in the last 2 slides, but to put it in a basic sentence, it's to assist, or whoever wants to take it, it is to become a full stack developer, to understand how each layer of the application works. So as a full stack developer, you need to understand how the database works, how you connect to that database, how a service layer works, and how your web layer works that is a representation to a website. So what we're going to be covering over a few sessions is this full stack developer. And it's every single one of those layers are going to be covered over the few sessions. And how those layers interact as well is very important, and that will be covered. Um, who should do this course? It'll be anyone that wants to become a full stack developer, or anyone that wants to learn more about the technologies such as Java, and one of the databases we are going to be using is MongoDB, Spring Boot, and so on. So anyone that wants to learn more about these things. And why do this course? It is that ability to learn new technologies and learn different patterns involving writing Spring-based applications, specifically this course. So throughout this course, I'll be covering primarily a Spring-based application and Spring-based technologies. And as we have different types of sessions, we might cover other topics. So we will be getting into Angular, which is separate to Spring. That's a front-end web framework, but that'll be covered later in this course. Cool. Some prerequisites that are required for this course. It's basic object-oriented programming. So just to understand a little bit of OOP, I have a little bit of Java knowledge. The version that we're using, or I'm using throughout this course, is Java 8, and you can use Java 8 or greater. It should work fine. We're using Apache Maven, which is a building technology and a dependency management for writing applications, and we're using 3.63 and greater. And I will be using Mac OS, so I'm using OS Catalina, a Mac to do the project, but and IntelliJ, but other platforms are fine as well. So even though I'm using Mac and I'm using IntelliJ, you can use Windows and you can use another IDE such as Eclipse, for instance, and it should work just fine. All the technologies we are using is open source, and it should work with most IDEs. Cool. Cool. This lesson overview, I'm going to be covering creating a Spring Boot application, a Spring project using Spring Initializer. I have a video on the YouTube channel already detailing Spring Initializer that I'll share in the end of this session. We have using Spring Data to create representations of database objects and repositories such as DAO, so data access objects. Implementing service layer and unit testing using Mockito. So as we're building the project, we will be doing testing. So we'll be taking a TDD approach, which is test-driven approach for this. And we will using use Spring Web to expose RESTful endpoints. So effectively what we're going to do is we're going to connect to a database. It could be any database. We're going to expose that data through a service layer, then use a Spring Web to expose it via RESTful endpoints. And that's going to come up throughout this specific session. Just a bit of, just quick to go over what is Java. I mean, everyone within this course should know at least what is Java, but just a recap on the technologies I'll be using. So we are going to be using Java, and Java is a general purpose computer programming language, class-based and object-oriented. So it's an object-oriented language, and it's key when it comes into the technologies that we're going to use within it. Look at Java as our base, and on top of that base, that programming language, we're going to use a set of libraries that was built in an open source community that will allow us to build applications easier. So the first technology that we'll be using is Spring Boot. And what is Spring Boot? Spring Boot makes it easy to create standalone production-grade Spring-based applications that you can just run. And what that actually means and what it means to be running Java is pretty basic. So I'm going to go through it. You can think of Java as a wheat, as something as a raw material, something that you can use. And that is effectively what Java is in this analogy. If you take Java and you apply some logic or you build on top of it, you can take Java and convert it into something else. So for instance, you can take Java and build a framework such as Spring. And Spring becomes the set of libraries that is within Java. So you would take a base language such as Java, you would somebody is doing work with it, wherever it is, and they will then produce a set of libraries or ingredients that you can use as a developer. So you as a developer can either go to Java and get Java, go buy a whole lot of wheat, go buy a wheat machine yourself and build an application with Java. That's perfectly fine, but much more difficult when you want to bake a cake. And if you go buy the flour and ingredients in the store, such as using Spring Framework, It's still a bit complex because you have all of these different moving parts, and ultimately you have to still put them together and bake them to make a cake out of it. So what I say is Spring Boot is taking that and it's actually giving you the cake. It's taking all the ingredients and saying, okay, we're going to take this complex language, which is Java. We're going to take all of these different ingredients, which is Spring Framework, which gives you libraries to do searching, accessing accessing RESTful endpoints or accessing a database. And it's going to convert it all together and say, there you go, there's a cake. You can go use it. And when I show you this initial example now, you're going to see why it's so easy and why Spring Boot works in that specific way. And one of the things Spring Boot works on is something called convention over configuration, which means basically, instead of you going and measuring how much ingredients, how to configure this application, you're going to give it to a baker. You're going to give it to these guys building this framework, and they're going to say, we know the best way of configuring it. We're going to give you the best possible, we're going to bake you the best possible cake out of this because we know the best ingredients. And that's what Spring Boot says. It's going to take Java as a language, which is your base ingredient. It's going to take Spring, which is a framework with all different libraries in it, which gives you ability to run RESTful services or connect to a database. And it's going to put it all together and say, there's a cake. And, at that point, the developer can take it and just change minor configuration, change what database he connects to, and the rest of the settings will be given to you by Spring because they use production grade configuration in Spring Boot. So effectively, they're giving you everything. And they're saying, guys, it's so easy to create an application now. You don't have to go configure this complex Spring framework, which uses XML to do configuration or even annotation, but it's a lot of configuration. They're saying, we'll take that framework, we'll do the best, we'll give you the best ingredients, we'll put it all together for you, and we'll give it back to you. At that point, you can take that cake, this analogy, and you can tell Spring, you say, well, I don't want sprinkles on my cake, and you can actually change that in Spring Boot with configuration. You can override the configuration they give you, because in some cases, when you write in this application, you're going to have your own configuration. So ultimately, you can say, I don't want a vanilla cake, I want a chocolate cake. And that can be easily achieved within Spring Boot when you apply configuration. So when I'm going through this, just imagine this, this concept where I'm taking Spring Boot, which is already a configured technology, and I'm applying specific configuration to it to change a little bit of its behavior, but not everything. I'm not baking the cake from scratch. I have a cake already. So in my mind, what Spring Boot gives you is a very happy developer eating cake. That's what I see, because it makes life a lot easier for you to build applications from scratch, to learn this technology. Because there's very minimal things you have to do, because the best developers out there that built this technology is the guys that actually configured it and gave you the best type of configuration for it. So they're saying, I'll give you a technology and I'll give you the best configuration. So effectively, you're going to the best baker and saying, bake me the best cake. I'm not going to tell you what to bake me, but give me the best cake you can. And that's what they're doing. Okay, so going on from there, we have what we're going to be using in this application is Docker. And Docker is effectively, it provides the ability to package and run applications in a loosely isolated environment called containers. Just know that Docker is here, and we're going to cover this in a lot more detail in further sessions. For now, just understand that I have a database running in Docker, and Docker allows me to run databases in it, and I can run many, many applications inside of Docker. It's just a platform for me to run applications easily. That's effectively what Docker is. And I'm going to be using MongoDB, which is a database. So there's going to be sessions around MongoDB, but MongoDB is a NoSQL database that stores data as JSON-like documents. Basically, JSON is a format that we use, and what's going to happen is this database saves it in a specific format. And with MongoDB, all you have to know now for this session is MongoDB is in the background, it's configured to run, and I'm accessing MongoDB. You don't have to know how it runs right now. It's more important that you know that there is a database that I am going to be accessing, and it's running on my local machine, this machine. With Docker and MongoDB, in my content, I'll load it on the video. I will give you instructions how to set up Docker and how to set up MongoDB in those in that video, in that description. Cool. So from here, I'm just going to kick off with live code. I'm going to open up start.spring.io. And basically what this site is, this site allows us to bootstrap a Spring Boot application that cake very well. So if you think about it as a bakery, it's saying, okay, give me all of these are my ingredients. This is what I want. So bake me the cake. That's effectively what the site does. So it tells you what project are you going to be running. Like I said earlier, we're running Maven, and Maven is a dependency management, and it allows you to run projects on it. So it has scripts that you can run that allows you to run a Java project. We're using Java as a language. We're using a Spring Boot version, which is 2.3.1. And Spring Initializer, this specific website defaults this version to the latest production ready version, and that's what's here. We can then configure some information around the application. This information configures Maven. Primarily, it sets up the Maven, what Maven requires to configure an application. So for instance, if the group is, I'm gonna set it to just my name for now. So it's za.ca.kuben. This is the group that Maven would use to identify this project. And you would use an artifact name, which is effectively how Maven would recognize that this project as well. So when you go and import projects, if you can build a project that you can share it, this is how other people will link to your project using your group and your artifact name. And I'll show you this when we download this project. I'm going to give this a project name, leave it as demo. So this is a demo project that we're doing, or we'll call it lesson. And this is just a description. So the name of the project is a friendly name. So you can name this with the uppercase or with the space. It's the name that it would use as a friendly name when you look at your project. I'm just going to leave it the same. Then we have a description for the project, which you can detail around your project. And we have a package name. And this package name is specifically used as the base package, which means the base folders for when you generate the application. So when you change your group name and your artifact, it changes your package name, but you can still modify it. So for instance, if I go say test, it adds it into my package name, but this is not fixed. So I can still go and remove test from that package name, which I just did there. This package name, as I said, will end up to be the base folders for your actual application. And most of your source file, most of your Java files that you're going to be running will be inside of this package. It's not fixed, but it's good practice, and that's why they set it up in this way. Your packaging, at the moment, you can select between a jar and WAR. For now, only you concern yourself with a jar file. Effectively, all that means it's like an exe file that you download on Windows that you can download an application and run it. So it's just an executable file that you can run with Java. The Java version we're going to be using is 8, as I said in the beginning of the course. So I'm going to be using 8, but you can use 11 or 14 for this course, and it should still work fine. On the right-hand side, we have dependencies that we can add into the project. And this is kind of getting to the point is, how do you want to flavor this cake? What do you want out of it? I'm still going to decide the ingredients for it. I'm still going to decide how much I give you to you, but you can tell me what you want from it. So when you open up, press the add dependency button, it brings up a list of dependencies that you can add into the application. So on the top, you have development tools, and I'm only going to cover a few here, few in this course, and over time we can cover more. But if you want to go have a look at these things, and they have a lot of descriptions, and you can go research on them, go to start.spring.io. I will add it to the description of this video as well, so you can go in and go and have a look at these different dependencies. But for today's course, I'm covering the development tools. So one of the development tools I use in all my applications is Spring Boot DevTools. It provides fast application restarts, reloads, and configuration for enhanced development experience. So effectively, this just makes it a lot easier for you to develop. So if you make a change, it can auto-compile. When you compile the project, it'll auto-restart that project really fast for you. I'm also going to be using Lombok, and I will be discussing what Lombok is when I'm building the class. But basically, Lombok replaces a lot of the boilerplate code. That means a lot of the code that you write over and over again, that's the same. So what it's going to do, it's going to use Lombok as an annotation, as a Java annotation to remove that code. So you don't have to write that code over and over again. And as you write a lot of code, a lot of this boilerplate code you don't want there, because it just makes, it just adds a lot of additional code that you don't really need. And that's one feature in Java that is there. And I know in the newer versions of Java, they are looking at removing this, and something like Lombok will become part of the language. And I think the later versions already started that. From the web technologies, we're going to be using Spring Web, which builds it builds web, including RESTful applications using Spring MVC, uses Apache Tomcat as a default container. So This is one thing in Spring Boot. So it says, okay, if you want to use Spring Web, I'll give you Spring Web with the starter with everything in it. So you're going to get the Spring Web library, and it's going to include Tomcat for you. So Tomcat is a container that you can run web applications in. So effectively, it's saying you can bring in web. I'll allow you to now build RESTful services. Use Spring MVC, which is MVC is Model View Controller, which is and you can also it'll also bring in a container for you to run it. So including this one library brings in a lot of tools for you. Just this one library, and that's what we're going to be using. So I'm just going to add Spring Boot DevTools, Lombok, Spring Web, and I'm going to add a database, which is going to be MongoDB, Spring Data MongoDB. As I said, for now, you don't really have to worry about the database. Just know that there is a database that I'm storing information in, so I can select it at a later point. So I'm going to include Spring Data MongoDB. Everything data related in Spring falls on an umbrella project called Spring Data, and effectively MongoDB falls part of that. So if you're using MongoDB is a NoSQL database, but if you're using a normal relational database with, like for instance, Microsoft SQL or MySQL, you'll be using a library called Spring JPA, and you'll be then including the drivers for that. But for MongoDB, you don't have to include that in. So all I have to do is include Spring Data MongoDB, which I'm going to do now. And I'm going to include for testing, I'm going to include an embedded MongoDB database. So what this will allow us to do, if you want to test our application, it will actually bring up an in-memory MongoDB so that we can test it without setting up a MongoDB on our machine for testing. Cool. So these are all the libraries I need to build this application with that RESTful endpoint. So the DevTools, Lombok, Spring Web, Spring Data MongoDB, and embedded MongoDB database. What I'm going to do now is download this project. All you have to do is click the generate button. That will download a zip file with the project in it, which I'm going to do now. I'm just going to name it. I have a project ready. I'm just going to call this. Cool. I'm going to open up the project in IntelliJ. I'm just going to move to my IntelliJ. I'm going to share that now. Cool. As you can see, I downloaded the project, and what I'm going to do now is open it up in IntelliJ. What I like to use is my command prompt, or in Mac, it's called terminal. And what I'm going to do is open up that file so it opens up in my IDE. You can open it in two ways. You can open it up via this, where you can actually go into the folder, which is Listen to Workspace. Cool. My project is open. IntelliJ is just a normal IDE, which means that it's a development environment that we can open up projects in. It allows us to run the project within this environment. So most of the developers that are in this session knows what an IDE is. So I'm not going to go through an IDE. I'll just show you how the project was structured when it was downloaded. So basically, when we generated the project from the website start.spring.io, it brought in a POM file, which gives you the libraries that we specified we wanted to use. So for instance, we said we're going to use MongoDB, Spring Data MongoDB, which it's done, it's added it in. It's also given us the web framework that we asked it for. It added it in, the dev tools, Lombok, and it added a few testing libraries. That's part of it. And it added also the in-memory MongoDB database as well. So what I'm going to do here, normally when I get my project downloaded, I build the structure initially. So what I'm going to add is a folder called domain, which is actually a package. You can see that this package name is the base of the application. And when we generated, this is what was shown on the website. And it created as my base package and gave me my initial file. This initial file is how the application starts. You can see a public static void main method. All Java applications start up with this method. So when you run this application, it knows to go run this specific method and start up a Spring application with this. So this is the Spring application, lesson 2 application, and it'll automatically do everything for me. On the top, you have an annotation at Spring Boot application. This annotation, all it says is this application is auto-configurable. So when it starts it up, it knows to go use whatever Spring Boot says is the best configuration for an application. So basically, all we did is downloaded the application from the web, and we're going to add in a few classes. Right now, if I start this application, if I click on the start button, it started the application. I have MongoDB running in the backend because it already established that I have MongoDB running. And because Spring Boot uses best known configuration, it knows if you download an application that more than likely, if you're going to run it on your local environment, you're going to connect to a local port for MongoDB. So it automatically knew that. So when I started the application now, it started up on the Tomcat server because we included Spring Web, and it hosted it on a specific port, which is the best known port for Tomcat, which is 8080. Normal Tomcat servers start up on that. So it auto-configured an environment, and it auto-configured which port it connects to. If I go to my browser right now, go into my browser. If I go to localhost 8080, which is that specific website, you'll see it comes up with a blank page saying a white label error page, because I downloaded the application, I got it up and running, but I really didn't tell it what to do. I didn't say, when you go to this path, what to show. So at the moment, it's showing you just a blank page, okay? An error page, because it doesn't know what to do. So as we add on to this application, it's going to expose these pages, because we're going to tell Spring to do that. We're going to tell Spring Boot, hey, okay, when somebody hits this web page, load something on it. Cool. So what I normally do initially is I'll set up a domain package, and I'll set up a repository package, which is going to house, which is going to have our data access objects, or our DAOs, and repository. And I'm going to add in a service package, which is going to house our service layer. And I'm going to add in a web package, which is going to have our controllers, our REST controls, to expose our application. So basically, the domain will house our entities, our objects. And if you think about it, this is a representation. Right now, this is a representation of a database table. We're saying we're going to create a class, and that class name is going to be, this example, we're going to create a post class because we're doing a project about liking something. So we're going to create a post. And that object comes in as a class. And effectively, what this class is going to be is a representation of a database table that we're going to be pushing data to. That's effectively what this class is going to be. Using the annotation for MongoDB, because as you know, we downloaded MongoDB into this project, and including that library allows us to have some of the functionalities, obviously. So what we have with MongoDB, we have a document annotation, and that comes from the Spring Framework data MongoDB that we include into the project as a package file. And what this allows us to do is say, I want to create a document, which is a representation of a table inside the database, and I'm going to call it posts, for instance. So that what this is going to do is actually going to, when you start up the application, it's going to know to connect to that database automatically. As you saw, yeah, it connected to my database. Yeah, this is a connection to MongoDB on localhost 27017, and it's going to create a table called posts when it does that. So I can write the information in there. At the same time, at this point, I can write a few fields that I need for the table. So these are properties that will be inside of that table. So for instance, I need a string of ID. So ID is the first property I'm going to use. Then I'm going to add a string of a subject for my post. And I'm going to add a string of a message. String message for my post. And because this course is called the like button, we're going to add in an integer of the number of likes. So we're going to add an int of likes. So this is going to house, this field is going to keep how many likes does this specific post have. In MongoDB, to save something in the database, you need to specify a specific ID column, so it knows how to access that data again, sorry. So that comes from Spring Framework data, so that's an annotation in Spring data. And if we include that, it knows that this column is a ID column for MongoDB. At this point, we can go and generate our getters and setters, because these properties are private. It means you can't access it out of this class. And in order to change these values, you need to have a getter or setter. So getter will get the value, and setter will set the value. So you can do it this way, where you can say generate, and you can generate getters and setters. As you can see here, I can select all my fields. I'll generate the getters and setters, and this gives me the way of accessing my fields and setting them. So for instance, I can call set subject, and it'll go set the subject on this class. So it can set the values on these things. What we'll do here is, this is a lot of code, right? You can see if I have 10 properties, this can end up to be a lot of getters and setters. And that's the reason why Lombok is here. So if I want to replace this, Lombok allows us to add an annotation called @data. What this does is build these methods for you automatically. So when you're using your application, it knows these methods are there. Adding this annotation removes all of that code. Lombok also has a method that, so if I generate a constructor, how do I construct this object? So I can have a blank constructor, for instance. Instead of writing the blank constructor, Lombok allows you to say no arguments to constructor, which is exactly the same as this. So I don't need this. So adding a few annotations allows us to build up this class without actually adding the code. And because it's boilerplate and always the same code, we don't have to rewrite the code constantly. So when you download and you want to go create a new table, you have to add these three annotations, for instance, and go add the fields, and everything is given to you. We can add an all argument constructor, which I'm going to add in for this project. And effectively, that will give you a constructor that gets all the fields. So if you want to construct the object, you can select all of the fields, and this will have a constructor with all of these fields in it. That's what this does. And this one is erroring now because it's got a duplicate constructor. Because when Lombok is looking at it, saying, hold on, you already have it, so it's erroring. So if I remove this, the error should go away, as you can see. I will also include another annotation that's handy in Lombok, is a builder annotation. And what builder does, a builder is a pattern, it's a specific design pattern to actually set values on construction of your object. Later in this tutorial, I will show you how the builder pattern works, but it's a way of accessing the actual class and then accessing inner methods on it to set the values of the class in a chained design process. Cool. So that's it. This is effectively our table. So we have a table, and we have all of the methods that we required due to these annotations. We have our constructors, we have our getters and setters. Because of @data, we don't have to write that code in this class. In our repository, which is our data access object, we're going to create a post repository. And that's going to be an interface. The reason it's an interface is because Spring Boot, again, gives you the functionality of accessing your data without writing much code. All you have to do is say, okay, I'm going to build a repository. I'm going to annotate it @repository, which effectively what Spring Boot says, okay, I know you now that you're bean, and you have bean of repository. So this effectively just tells Spring Boot that you exist. So when you run your application, when you run the application, it knows, okay, I have this class and I have to have it available so my rest of my application can access it to write to my database. At the moment, you can see there's no method in this specific class. But Spring Boot also gives you a set of methods that it will implement for you when you extend a class that it provides. So you can go and extend something called Mongo repository, which gives you a set of methods. So if you go into this class, if I go drill into it to go look at the code, Mongo repository will give me a way of saving all my data, for finding all my data in a database, for inserting data into a database. There's a few methods, and it extends additional paging and sorting methods and querying methods. So you can have a whole lot of methods given to you out of the box with Spring Boot, because it automatically implements these methods for you when you run your application, because it knows that this is a bean. It's a object that it has to control because you added the @repository. And because you extended Mongo repository, it's going to give you all the methods out of this specific class when you run it. At this point, you need to supply two things for the repository. It asks for T and D, which is effectively the object type. So T is the object type, and ID is your ID type of that. So if you go back to your object, which is your table, it's of type post, because that's what the class name is, and the ID type is of type string. So I'll go in here. I just have to say this is of type post, which is the object that I'm going to be accessing, and it is of string ID type. That's all you have to tell MongoDB. That's all you have to tell this repository, and it will now automatically know how to auto-wire this specific application. It will start up. If I stop and start again, it will be able to create a connection to the database, understand that this is now accessing the database with no issues. So I built a way of accessing the database, and it starts up with no issues. That's effectively what a repository does. It gives you access to your database using a entity representation or table representation, which is of class, this class of post, using these fields. This is slightly different for the relational databases like SQL and so on, but the concept is very similar. So there might be slight differences between the two. Okay, at that point, we have our repository. That means we've added, at the moment, we created code of maybe 7 lines, and we already have access to a database. Now we're going to add our service layer. And what I normally do for a service layer initially is create an interface, which is effectively a blueprint for my service. And I'm going to implement on that interface. So I'm going to build this interface to say it's a post service. This interface, what you do is you actually telling it how your service will, what methods your service will contain. You're not telling it how the methods will work. You're telling it what it will contain. And a reason you use an interface is to allow you to do multiple implementations of the interface and switch out implementations for future projects or future changes. Because if you do not use this interface now, especially on your service layer of your application, if something changes, if we have to change from MongoDB to SQL, for instance, it becomes a lot more difficult for you to change that logic. Hence why I use a service, so you can do a new implementation of this service to say, okay, at this point, I want to select my data out of using a SQL database, or even using MongoDB, but accessing MongoDB in a different way. And the benefit we have with this, and during this course, I am going to be doing 2 implementations, not in this lesson, but in future lessons, I'm going to do an implementation today that's going to show you how to implement an endpoint, how to implement this service connecting to your database. But in the next session, I'm going to change that out and do a totally new implementation of that same logic. Cool. So in this method, we're gonna have get posts, because we're gonna get all our posts from the database. That's gonna return a list of posts. So effectively, I'm telling this service what methods I'm gonna have. So I'm not telling it how it's gonna work. I'm just saying it's gonna have these methods. So I'm gonna have a list, which is get posts, which is gonna return a list of my posts. So basically, what you're saying is, go to my database, and what you want this method to do is go to the database and return me a list of all the posts that I have in that database table, which is of post. Then I will have a method which will return a single post. So we'll call it get post, which is a single post. And we're gonna pass in the ID. So we're gonna say, okay, what you can do is, if you wanna get one post, you can get that post by passing in the ID, and we will return an object of post. So we're gonna return one of these post objects sending through an ID. Again, I'm not telling it how it's gonna happen. I'm just telling that I need it within this application. Almost you're designing the application using the interface, and then you're going to build your code onto that interface, using that interface. We also need a method that will be, okay, so let's go like post or save post. So we're gonna have a method that returns a post after it saves it. So we can have a save post method, and this will enter a post object. So we're gonna say, okay, we need a method that we're gonna pass in this database table, this representation of these values into a method that's gonna save it into the database. So basically that's what save post will do. And the last post, as you remember, we added a field called likes. So we need a method. So now we need to plan out what method we need. And we're gonna have a method that actually returns a post, but we're gonna like a post. The method's gonna be like a post, and we're gonna pass through the string of ID. So what this is gonna do, it's going to pass through an ID, and we're going to increment a number of likes this specific post has. And this can only happen after the post is created. So those are the only methods I need for this application. At this point, what I can do, I can see on time we're not going to do great. So what I'm going to do is we can run through a quick unit test of how we would test this before we even implement the logic. So we're going to build a test that says, I expect certain things to happen. So if it fails, I know that the code is not working. So that's what we're going to do now quickly. Cool. So if you go hover over the name in IntelliJ, you can click on a light bulb, and most IDEs can do this. I can say I want to implement this interface that says I now want to tell you how this code would work, how these methods would work, and I will create it in a folder called IMPL, which is implementation, short for implementation. So effectively what I've done now is created a class, an implementation of that service that I said I'm going to build something with, and I didn't tell it how to build it. And I said, okay, there's all my methods here. It's working off this blueprint of this specific set of methods that I need. eventually, and now I have to implement it. So now I have to tell it how to work. But before we do that, we're going to go create a test and tell it what do we expect when it works. So we're going to tell it what we're going to return back. So all I'm going to do now is highlight over it again. It's going to say you can create a test for the specific class. I'm going to call it post-service implementation test. Sorry, we can create the test on the service itself, on the interface. So create test, but we're going to test the implementation. So we're going to create a test, say this is a test. We're going to test every single method on the service and expect a certain result. So this is test-driven programming. So effectively, we're going to write the test before we even write the code. So we already know what to expect when it comes to the specific methods. So we're going to actually write the test to say, okay, this is what I'm going to return. We are going to use a library called Mockito to mock our repository, because Spring is automatically implementing those for me. So therefore, I don't have the logic if I'm going to test the logic from an application. So I have to mock that specific logic in my test. So if you go on the test now, after I created the test from here, I'd add it to your test package under the same structure. So when you create a test on one side, under your test folder, it'll follow the same package names, and your test is under here as well. So there's your test. I'm quickly going to import a library called Mockito into my POM file. Spring Boot doesn't have it when you download it from its dependencies, but at the same time, you can go add your own dependencies into this application. You can go say, I want to use another developer's library. I want to go use somebody else that did something. For instance, you can go download a library that will take a string and split it into 5 words if you want. So you can use any type of libraries you want, and that's freely available on the web. There's millions of libraries. Quickly going to download it now. Give me a second. Cool. Under the POM file, I'm going to include a new library on the bottom that's called Mockito. Mockito is a testing library that allows me to test my application and mock specific logic. So that, which means that if I want to test it without connecting to a database, this can mock your database calls and say, I'm testing my logic. I'm not necessarily testing how I'm saving to a database. Testing to save to a database, we'll probably cover in later sessions, but effectively what that is, that's called an integration test. What we're building here is a unit test. The main difference is with a unit test, you testing your code, your logic of your code, and in a integration test, you're actually testing that you can connect to a database and you can save to the database. You are testing logic and you're testing integration. The reason why you would use unit tests over integration tests are relatively slow. So when you're running builds and you just want to test your logic, unit tests are extremely faster to do that, because when you run an integration test, it has to start up a database. You have to ensure that the database is available. You have to create test data in that database and so on. So integration tests are a lot faster and allows us to test our logic quicker in that way. So basically, we're going to test these different methods. I've already have some code that I'm going to just paste in here. I'm just going to cover over it because we won't have enough time to go through and write all the code in. So give me 1 second. I'm just going to copy it across. Cool. First thing, as I said, with Mockito, we want to be able to mock a service. And what we're going to do there is mock our database access. So what I said earlier is that with Mockito, you can mock certain things that are required by integration tests, such as a repository, which accesses a database. Because when you're running this test, you're not actually accessing a database. You're just going to mock what the database would return. So you're going to stub it, you're going to give it a result before it hits the database. You're going to say, and I'm going to show you the method how that works now. I'm just going to bring across, okay, cool. So that's my repository. I'm going to statically import all of the Mockito libraries, which I'm going to do here. So it accesses this mock. So I've included the library in my imports to access mock directly. Otherwise, I'll have to go call mockito.mock. This way I can access everything in Mockito, which is, yeah. Cool. I'm going to say that I'm going to mock this repository. And later on in each method, we're going to mock it. In each individual method, we're going to say what to do with a specific method when we call it. So the first thing we would do is we're going to set up. So before the test run, we're going to set up some test data. So what I'm going to do here is copy just a few variables into the test, and I'll explain how this works. Cool. Our implementation of our implementation of our service we have to go in it because it will require the repository. It will have to access the database. To do that, we'll have to add a variable for that repository. So we can add a public, private final post repository into the specific class. Now that we're trying to actually test it, we know that we have to access the database. So you add this in, and then you can say add the constructor with that specific variable. So we're saying when you build this object, ensure that this variable is set in. We can then use an annotation called auto-wired. Effectively, what this annotation does, it says on this annotation, I labeled it at repository, this specific repository. So this annotation on my server says, go look for this specific object. You can have multiple here, but in this case, go look for this object. Go look for this object. Spring, go look for it and tell me if you have it and push it into this. So this annotation tells Spring, hey, go and add this so other applications can find it. This annotation tells Spring to say, hey, go look for it and place it into YAP. So one is placing it into Spring as a bean, as something in memory that you can access. And this is telling the application, go find it and place it in here so that I can access my database. The difference between these two annotations. This one is adding it in, and this one is extracting it out. And that is the concept of dependency management. That's the basic concept of dependency management, which means that you're adding something in that you can use at a later point. So it adds it into, you can call it a set of libraries or beans, and you can use specific keywords to bring that libraries or those classes in on other classes. And this is what I've done here with the auto-wire. So you're telling Spring when you start up, access it, and then set my post repository variable to that value. Cool. Going back to our test, now that we have it in there, you can pass through your mocked repository and you say, I'm building the service. So I'm saying, I'm setting a new implementation of the service using this, this repository, which I'm injecting manually, because remember, I'm not running the application and integration test, therefore Spring doesn't know this exists. So I'm forcing it using this, this mocking to say, hey, go and add this into the project because I'm telling it to do it. Spring does this automatically for you. So when you start your application, this set of code that you see here, except for the mocking, it'll go and establish this and add it into it automatically, so you don't have to add the code. We're going to add a new post object, which is going to be just a standard post object that we're going to use for our testing. We're going to add a saved post object, which is after we save it, because remember, when we mock a specific save, we want to get the save back of what it would look like if we're actually running a database. So we're saying, there's our new post, there's our save post. So when I call this, when to save it, return this. And that happens on a mock. So starting off with the first method, getting all posts or getting posts, what we can do is add in a when. So effectively you can say when, and this is Mockito. When you're calling the post repository find all method, when you're trying to find all, which is what we're going to use to actually run to get everything from our database, return a list, my saved posts. Then return a list of my saved posts. So what effectively this is doing is saying, when this runs, return this, mock this, because I know you're not going to be able to connect to the database. So I'm just telling the application, if you're running a test, if this is invoked or run, return these results. So this will never actually run really to connect to a database. It will get short-circuited, and it will return this immediately. That's effectively what Mockito does. It mocks your results so that you can test your application without running an integration test. At that point, now that you're mocking it, the method that you have in your service that you want to test is get posts. So you can say post service, I'm going to test get posts, and I'm going to return that value. So I'm going to return a list of posts that I expect. At that point, with my return, I'm going to assert that this is not null. So firstly, this value is not null. So I'm going to say that whatever I return here, because I'm returning the set of results, this shouldn't be a null return. But remember, we didn't even make any logic in this specific test yet. So more than likely, what's going to happen is this test is going to fail because we haven't told it what to do yet. The next test I would do is say assert assert equals, and we're going to do post.size. So we expect a specific side back. So it's post.size. And we're going to say that we expect it to be 1. So we're going to expect one object. Because if you see up here on my setup, I'm adding only one save post to the save post list that I'm mocking. Okay. And the next test I would do is assert equals again. And I'm going to assert get the first post. So post.get out the first post, which is of 0, so the first element in this array, and ensure that it equals my save post. This specific save post on top here that I created that is saved. So effectively, I'm saying, go and mock this, return my list of posts. So in here, so when this gets called, when it calls this method, mock it, and then check that it's not null. Check that the size is 1, because you should only return 1 result. And also check that the first element of this list is of this one element here. So if I run this test right now, if I run this specific test, this unit test, it's going to fail. And the reason it's going to fail, it's going to say it's null. And if you go into the post, get post, you can see why. Because if you go to the implementation, it actually has no logic. It's just returning null. So now that we have a test and it failed, let's make the test work. So if we know the test works, we know our application is going to work, because logically, we know what to expect. So all we have to do here, I mean, this is a very basic example of a test. All I have to do is call my post repository that I said I'm going to be using. I'm going to say I'm going to find all the records for this, and that's it. That's an implementation of that test. If I go back to my test and I run it again, it should pass, hopefully. It's going to test all of those 3, and it did. So it went through it tested it, and all of the tests passed. So effectively, what we did is we created a method with no implementation. We're not even telling it how to work. We went to a test and said, this is how it should work. So therefore, when we write our code to actually implement that specific method, the test has to pass. If it fails, that means we haven't implemented it correctly. If I went in here and I decided, because you can go in and say, okay, let me just return a new list instead of a null, right? A new array list, sorry. Let me return a new array list. So logically, this is not going to return null anymore. It's going to return a list. But will your test pass? Let's run it again and see. So this failed as well. Okay, cool. As you can see here, I ran this test now, and it still failed because it expected one result back. I created an implementation of the method that doesn't fit the test. Therefore, the test will fail. Therefore, my application won't build. So if your tests fail and you're running an application, if you're building an application, the actual application will fail to build. So these things, tests are a way of guaranteeing when you're continuing to add more logic into a method, or you changing something in the method and you run your application and it fails, that means you change the method in such a way that it damages the expected result of that method. So therefore something changed that should not have changed. Then you have to go fix the method. So if somebody mistakenly changes this get post method that we just implemented to say new array list, then your application will fail to build, and you can't get that application into production. That means you cannot deploy it, and it will never get to a user, so they can never access this incorrect code. So tests are fail-safe on that, and test-driven, test-driven TDD is very important because this allows you to have more stable and more reliable code, because you're always ensuring that it works in the correct way. That's effectively what the test does. We can go in and add a whole lot more of these tests, but given this current time of how it's going now, I'm just going to start with the controller because we're going to run out of time. But basically, you can go in and implement all these different tests with similar logic to this, and it should return your results. What I would do is just do the like posts test, and I'll show you all specifically why I'll do the like post. Because the like post is supposed to go in, find that specific post, and then go and add a like to it. So you're incrementing likes. By default, when you create a post, it's going to set that to 0. So what you're doing is you're going to say, I'm going to go like that post, and therefore it must increase to 1. Logic. This is a business logic understanding of what needs to happen to your method. So I'm not even talking about database. We're not even saying you're going to save it. We're saying logically, we're going to go and have a post. We're going to increment it to 1 and then give it back to the user saying, there's the amount of likes on this post. And that's the test I'm going to do now. And that's probably the last test I'm going to do. And then I'm going to go into adding the RESTful controllers to the method, to the application. Cool. So liking a post or like post, what we're going to do first is we're going to say we're going to find a post. So we're going to say when we call our post repository find by ID 1, which we expect because we created a save post of 1 as a mock. We're going to return that's the save post, but we're going to return an optional of that save post. Basically, from Java 8, they introduced something called optional. So a result can return. If it doesn't return, it can bring an optional that's empty. That means it can return a null, or it'll bring the optional of the value. In our case, for our test, for this specific test example, we're going to return an optional of that specific save post. So we're going to tell the repository when you run this method, return this value, optional value of this. We're also going to say, because this method is a little bit more complicated, we're going to say, when you're saving this method, when you're saving it in the repository, return a save post. So take the post that I just have, go do your logic to it, and then go save it into the database and return me back that post. So basically all I'm saying is I'm passing through this object by its reference. I'm going to do something to this object, and then I'm going to save it. So what I'm going to do with it is I'm going to say, I'm going to go and call the like post method. I'm going to say post service like post. I'm going to go get the post by ID 1. I'm going to return a post back, and then I'm going to expect a certain set of results. I'm going to say I expect for you not to be null, because I am sending you a result and I expect you not to be null. I expect for you to have an ID of 1, because the one I'm saving, the save post has an ID of 1. This is so we know this. And then I expect you to have a count of 1. That means I'm sending through, if you look at the object, I'm sending through likes of 0. So when I run this, I'm expecting you to return me back a 1 because I liked your post. So from a logic standpoint, it must tell me that I sent through an object, I incremented the amount of likes, and I returned you back that object with that amount of likes. So you incremented it by 1. Going into this method, so like post, now that we can do this, we can run this, it'll fail because we haven't implemented that method. We actually haven't told the method how it should run, what to expect. We haven't told how to run, but now we know what to expect. So if we go in and we go build this method, we know we have to have something that increments a like. I mean, first off, it has to return an object that's not null. Secondly, it has to have the ID that it's coming through with. And the third point is it has to have an incremented like. So there is logic that we have to apply here. So almost you have written a technical approach to how you're going to build this method inside of this, because this has logic. So basically, in this like post method, what we're going to do first is we're going to find that specific post. So we're going to say post repository find by ID. If you go look at the mock test, post repository find by ID, we're going to return this optional. And what that returns in the implementation is a optional. So this will return you back an optional value. So now we're already telling it, hey, when you call this, go return that optional value that I told you to return. So I'm going to do a .get right now. This will change over time, but you can get null values on this. So you can write additional code to cater for nulls. But for now, for our example, I'm going to say .get. So now I expect this post to be that post that I sent in when I was testing. From here, what I'm going to do is, now that I got this post, I need to increment its count. So there's one way of doing that. So there's multiple ways of doing that. But the only way I have available to myself now is to get the likes, right, and add 1 to it, and then set the likes back in. So what I'm doing there is saying this field that's eventually going to be saved in my database, I'm going to get the amount that you have already, and I'm adding 1 to it. This is actually a very bad implementation of the code, but at the same time, it's going to work. So if you go into here and you say, save my post, because I want to save it. Now that I added the like to it, I'm going to save this. I'm going to save this and say, okay, I've got the post now. I've added 1 to it, so I'm going to save it. And at the same time, I'm returning, because this save returns me back my object of S, which is my post. So it's saying save, return that save. Lekker. So this method is now implemented, basically implemented. If I go run this test, it should pass. It passed. So it ran this test and it passed, that means all the logic that I just implemented was correct and it's working. It doesn't mean that the method is built in the best way it can. Just this is a very limited amount of code in this method, and it's saying one, but there's one fundamental problem with using the setLikes method. And the reason for that is because this value should be, in Java and object-oriented programming, this value should be encapsulated, because you don't want anyone to access the likes. You don't want anyone to be able, not access, anyone to go override the likes, because the only way you can increase a like is by adding one to it, not by overriding it. So if I mistakenly go and change this method and set it to one, even though my test returns, so I set it to one and take out the add, so even though I run this test, even though I run this test, it's going to pass. I'm going to say, well, I'm going to look at my senior developer and I'm going to say, hey, well, I wrote my code and I wrote my test and everything is working. At that point, what you would normally do is you would write two tests, a negative test as well. So you write another test, the test like test 2, and you'll pass it in and you'll pass through another value of 2, returning a different save post, and you'll expect 2. So you'll do 2 tests. You'll do a negative and a positive test. Actually, this is another positive test, but if you do this, this value should not equal 2, for instance. So when you go deeper into testing, and we'll cover that in later sessions, we'll go into what is negative testing and what is positive testing, and how many of those negative and positive tests should you have per method. In some cases, you might have more negative tests because you have more scenarios in that method that you need to cover. But for now, basically this test passed. And if I go back into the method, it's implemented, even though I'm setting the like as 1, it's a very, that was wrong, obviously, even though my test passed, and even though this is still wrong. Because I don't want me designing this application that says, hold on, yeah, no one should have the access to set anything over my likes. So what should I do? You go back into your object, that representation, and you say, okay, let me add a new method. And this method is going to be a public method that I can access out of this class. And what it's going to return is void. So I wanted to do something. And what I wanted to do is add a like. So I'm going to tell it, instead of going and setting this likes and increasing it, I'm going to call this likes in my method. So I'm going to say this.likes, which just means this is this class. I'm calling the property likes. And I'm going to say I'm going to increment it with a double plus. This is an incrementation. So you're saying double plus, which auto assigns it. So it'll take the number of likes you have and increment it. And basically that allows you to not be able to override this. Unfortunately, with Lombok, the setter is still in the code. So what you can do, you can add a method annotation that says, for this setter, Lombok has a way of doing it. You can say access level none. So you can say, you're not allowed to access this setter, I'm sorry. So if you go back to my code, if I compile it now, it's going to start breaking first of all. It's going to say, this set likes doesn't exist. So I can't access it anymore. So now as a developer, when I was developing this code, if it was designed properly from this point, if the developer that designed this entity said that this should never change, it's encapsulated in such a way, it is restricted, it's hidden, that no one should ever access my setter method for this specific property. If it was developed there, then the developer building the service would never have had access to that specific method. So he could not have done it. So the only way you could do it is saying add like on the post, and that will do it. So effectively, we replace the code. So if we go back into our test and we run our test, this test should pass. And it still passed. So we took a test that we wrote, we implemented it in such a way that it passed and the logic was correct. We took it in a way we implemented incorrectly, but the logic still passed. And we took it now and we refactored it into a way that is substantially more secure for the application itself, because nobody has access to set over likes by mistake, for instance. And the code is now works in a much better manner. So when you go and implement more tests for this, you have your behavior already set. So you cannot override the previous like values. It'll always increment on the next like that you have on that object. Okay, so basically that covers tests. These tests are the same as this. So it's a basic test where you say, get a post, return a post, make sure it's the same post, and saving post is the same. I'm going to send through save post and it'll return a post. This is the only logical test we have, and the logic that we have, even though it's basic, covers how testing is important and why testing is important. Just a basic test like this. Cool. From here, I'm not going to implement these tests. I'm going to actually now create the web controller because I just want to check the time quickly. Okay, it's 7:15. What we're going to do now is we're going to go into this implementation is complete these two methods because we have these two methods that we didn't implement. So basically, yeah, we're going to call post repository get find one by ID, find by ID, and we're going to return back the object of .get. We're going to return this specific object by this ID. And then we're going to save a post. We're going to call the post repository again. And Spring Boot has given us another method called save, and we're going to save the post. So what we did here is Spring has given us all the logic to connect to our database. We just added one-liners that's already given to us. We exposed and accessed a database with these few lines of code, which is already given to us. And when we access this code when we run the project, it'll automatically implement this. It will connect to the database for us. And now that we expose it on RESTful endpoints, I should be able to run this application now. Let me run it again. Cool, it still started, there's no issues. And I would recommend if you're building this application and if you're trying out this example, I would suggest that you'll go in and start your application now and then to just check that everything is fine, or even run the compile button, which will check if any errors have come up in your application. But at the moment, what we've done is we set up the post entity table, which is a representation of a database table that we're going to be saving data. We set up a repository, which is a way of accessing that table and saving the data in our database, a data access object. And we then created a service interface that allows us to change the logic of how the service works over time. And we created one representation of an implementation for the service. So we created currently one way of doing this. And in probably in the next or the following session from now, I'll be showing you all where I'll have this implementation. I'll go create a brand new implementation, not using the repository at all, and it'll still work exactly the same way. And all my tests will pass. But for now, what I'm going to do is create the web layer. The web controller is what's going to be used for you to access this methods, for you to access this data, for you to save this data from a browser using a URL. So basically how this works is you would set up a new class, similar to how we set up a post service. We're going to set up a class called post.controller. There's many names for this. You can call it post web. Some people call it post resource. But basically, it all means the same thing. It's just a way of accessing. It's a controller to access your service layer in this case. So give it endpoints or give it a way for an external application, something outside that can actually access the data within your application. What we would do here is we would add an annotation, and that annotation is similar to we added at repository. Now we have to tell Spring, what is this class? At the moment, it's nothing. It's just a plain old class that can't do anything. But once I go in and say, I want to make this a REST controller, I want to make this something that we can expose externally in a REST format. So REST is just a format. REST is a way of representation of the data that we're going to expose, and which is JSON. We can ultimately use JSON to expose the data. And all we have to do is call it REST controller. That automatically now says, hey, I know what you are. You're a REST controller. And I will be able to, this will be able to, anything you add on here that gives me a mapping, I'll be able to access externally out of this project. And also in further classes, we'll teach you how to do security, how to secure these REST controllers, how to secure some of the methods that we're going to create, okay? So now that we created a REST controller, we have to say, how do you access that REST controller? So I'm going to add a request mapping. So another annotation that Spring gives you. How do I get to this? How do I map a request to the specific controller? And I'm going to say, I'll give it a URL / because all applications start up, like I showed you earlier, localhost 8080, which is your port, and this is how it's accessed, localhost 8080. Anything you add here will just add on into this specific into this URL. So I'm going to say, because I'm creating an API that exposes data, I'm going to call it API. And because you want to follow standards and the right way of building an API, you give it a version. So I'm going to say this is API version 1, which means I can go create a new controller later on that does a whole upgrade my logic without affecting my level 1 API. So it's just a mapping. So I can go create another one of these controllers and have it version 2 and then upgrade my functionality. And when it's ready and tested, all I have to do is switch my web application to say, hey, point to this URL, API version 2 instead of API version 1. Cool. Okay, going in from there, we're going to create our first method. And the first method we're going to create is getting, we're going to return that list of posts. So we're going to say we're going to get posts, right? We're going to get that list of posts, and it's going to accept nothing, and it's going to return, we have to return something. Now, if you go back to our service layer, we have a post service, and obviously on that method, we have our method get post. The one thing you would notice if you looked at my repository is that I added at repository, and my controller added at controller. That means Spring knows about this. But if I go here and I say, I want to include private post service, which is the service that I'm going to use, I'm going to bring that in, and then I'm going to call it the final and inject it. Using constructor, I'm going to inject this value, generate constructor, and I'm going to say this is at auto-wide. But this is still an error. It's still saying, hold on, yeah, there's a problem. And what's the problem? Is that if you go to my service, my implementation of my service where we put the logic, I didn't add anything on top here. So Spring doesn't know about it. So you can't run this. If I run this application, it's going to fail because you can't find this. Where is this? It doesn't know because you didn't add it into a reference point for Spring to say, hey, this is a different class. If you want to access this, I have to add another annotation. So on here, you add another stereotype annotation, and that annotation is called service. So now Spring says, okay, cool, I know you're a service, and I will add you, I will make you available to be referenced from other classes. And if you go back to my post controller now, error is gone because it knows that it can be injected. So that's basically what happened there. So I took this class, added at service, and now Spring Boot is aware of it. Spring is aware of it, so it knows that it can be injected in other classes. Again, going back to dependency management, this is what dependency management is all about. And that's established that dependency, and we'll be able to inject it here. Cool. So the get post method, we're going to implement this method, and we're going to say we got the post service now brought in, and we can say get post. We've created this method. We said go get the data, but we didn't tell the application how do you access this method. It knows how to access this controller by API version 1, but we haven't told it how to get to this method. So all we have to do is say Spring offers a few annotations for this. So the annotation that's the easiest to use is get mapping. So it's going to say, if a web browser tries to get me, which is a command that you run from a web browser, it's get, put, post, and we run delete. There's a couple other options. But ultimately, this get command will say, hey, you want to get something from me. How do you want to call it? I want to call it with /post. So I'm going to say, hey, go and give me all of my posts that's available to me. Go give me everything via this URL. Right now, if I start the application again, it's already started up. So the Spring Boot Dev Toolkits that I showed you earlier, all I had to do is compile my project. It knew there was changes and automatically live reloaded my application for me. So if I go back into the browser now, let me just share this quickly. So I'm back in the browser. And if I go to, we said API version 1 posts, it says, hold on, okay, I'm not giving you an error anymore because I know how to get to this part of the URL. And I know what you mean by this, and I'm bringing back a blank list because we haven't saved anything in the database. So what we've done is we exposed an endpoint. We exposed this endpoint here using these two annotations and said, go return a list. And because the database is empty at the moment, because I just created it automatically, it doesn't have a list of posts that we can use. At the moment. Let me stop the application. We're going to create two new methods. We're going to create a method that actually for saving your record. So at this point, what you're going to do, when you save something, that means you're posting it in. That means you're going to post an object into the application. So we're going to say at post, because that's what it's going to be. And we're going to post in a post. So we're going to say, we're going to post in with the URL post, and we're going to save something. So we're going to create a new method called public, and we're going to return a post object that we're saving, and we're going to call this method save post, for instance. What this is going to do, it's going to use this URL. It's going to be a post method for you for using it, and we're going to return the post service to be able to create the method save post. The one thing now is you notice that we need a variable. We need the post that's passed in. So Spring Boot also gives you an annotation to say this request body, whatever I'm sending in from here, comes through this annotation and says, okay, whatever variable you determine here will push that value into this. So effectively, you're saying he's going to send me a post without an ID. So he's going to send me a post object. I'm going to save that post and return it to him. So this request body says, whatever is in my request body, whatever I'm pushing through, take it and save it and return something back. So that's what it's saying. And this is saying plug it into this variable when it's bringing in. So that's what a request body is. Cool. We're going to add another method, which is going to be like. I'm going to use a get method to do the like as well. So I'm going to say get mapping, because I'm not going to post any data in. I'm just going to send the ID. So I'm going to say post. I'm going to post. I'm going to pass to an ID. So I'm going to say this specific ID. I want to do a like. So I'm saying for post object with this ID, I'm going to like it. And the method's going to be a public method that's going to return a post. Because we said when we like it, we're going to return the value that we like, the new post value. And I'm going to call it like post. And this is all it's going to have is a string ID, which is this, this squarely brackets, and this inside of this means that it's a variable. That means that in your browser, you're going to say post an ID and you're going to say like. So you're going to put in a value in between, And what this will do, Spring will push it into this if you annotate it with a annotation called path variable. What path variable does, it says, okay, you can see it was highlighted before. If I take this away, it's got a line below it and it says cannot resolve it. That means it can't find it. So when I added the path variable to it, annotation, it says, oh, okay, I know that this variable links to this. That's basically what path variable does. Similar to request body, it says whatever you're posting in, whatever data you're sending me through your web browser, I'm going to take that and push it into this object. This says whatever you're sending me via URL on your path, pass it into this variable of ID. Then I can call my post service again and say like post of that ID, and it'll return it. So that method is now implemented. The last method is get one. So we'll quickly copy this. That's going to be get by ID. So we're going to do post. We're going to put the variable of ID again because you're getting the one by ID. You're going to call it get post. We're going to have a path variable that's going to link to that ID. So path variable of string ID. And the method we have is get post, because that's what we return. And what we're returning is a single post. Okay, so what we've done here is now we exposed all of these different services and into, so it's accessible via browser. Browsers, websites, or Chrome, for instance, all of these requests here is a get request. I'm getting something. You can post via this, but it has to be written via inside of an application that you can post. So for the means of this specific course, what I've done is I've created an application using Angular 9 that's going to be covered in later sessions. I've already built it. I'm going to show you how that application will work. All I have to do is start it up, and then I'll be able to access these methods. So I'm going to do that in the background now. I'm going to start up this application. Cool. And actually, before I do that, I'm going to show you all using an application called Insomnia. Insomnia is an application that you can actually call URLs and do posts and get. So you can install, there's an application called Insomnia, and I'll link it in the video. There's an application called, I think it's, I forgot the name, Postman, that also does the same. So all you have to do is say, okay, I want to do a new request, and this request, I'm going to call it my post request. And we're going to do a saving request. So we're going to say, okay, I want to do a post. So it tells you what you're going to do. I want to post. I'm going to post via an HTTP call to my local host that this application is hosted on, 8080. I'm going to slash that, say, hey, I know how to access you with API version 1. And what's my post command? My post command is post. I'm going to pass through an object. Cool. So I'm running post here. So you would think we added REST controller, like I said earlier. REST uses JSON as a format, as a type, a format for your data. So under your dropdown for your body, you can say this is your request body. So this request body equals this body here. So effectively, whatever you put in this body is going to be sent and popped into this request body. So if I go and say I want to send through a JSON object, and I'm going to create a JSON object, we're going to cover JSON in future sessions. What this does, you say, JSON, I know that I have a subject that I have to pass in, so a value test subject. And I know that I have a message that I'm going to pass through in my post. So it's message. I'm going to have a test message that I'm going to pass in. Cool. So this says I'm going to post this body. It's going to call this method and save it to the database, right? It's going to call this service level. And if I breakpoint it and debug it, which I think best way of showing you how this actually works. Cool. So I'm going to say send. So I'm going to send a post to this URL. If I press send, it stopped because it hit my breakpoint. So I'm debugging the application and showing you what happened. I send that in, and because of request body and because I sent it into the body, it says, okay, I know how to map you. I know that you have a subject and a message, therefore I can map those two values in. And that's what it did. It took that JSON object, which is this, and mapped it into an actual object that we can use in Java that represents our table. So already just on the base of that, we have a representation of how our object is going to be saved into the database. We're going to call our save post method. So if I go into this and I put a breakpoint and I just play this through, it went into this method. It says, okay, I'm going to save you into the database. And if I clear this and press play here, it's going to hit my database. It's going to say, I opened up a connection to your database and I saved this value. So now the value is in your database. It's there already. If you look at the response, it said, hey, I created an object for you in the database, and this is the ID it gives. So Spring gives you a kind of a good ID. It's a random ID. It created with the subject we sent in. It created with the message that we sent in. And it also said you have likes of 0 because it defaulted to 0 likes. If you go into the database itself for this application, if I open up the database, which I'll show you now, what I'm going to do is change the name of the database so I know which one it is. So going back into my configuration, I'm going back into application properties. I'm going to say mongodb. I'm going to say my database name is lesson database db. I'm going to stop my application. Set it up again. So now effectively what I did with Spring is said, okay, my database for this. So imagine if you're moving to a production environment or a different database, you can go change the name of which database you're pointing to. I started up the application. I'm going to go post this in again, which brought me back an ID. And if I go to my database is available on my local host and I refresh, I should see that database created. Lesson DB, there we go. It created the database automatically for me. It created that collection, which is effectively a table. And in that table, because I saved the one record, there's the record in there. So by changing one property, Spring Boot knew exactly what to do. When it created the database for me, it knew how to create a new collection for me. And when I posted to it, it went and saved it in there. So Spring Boot is doing all of that under the hood for us. It's configuring that. It's linking everything together. All we have to do is say, call a repository, say save, and to configure it to our needs, all we have to do is change one property. We have to change the database name property. And again, with all the properties under here, you can go configure the way you want Spring Boot to run very granularly. I mean, you can change a lot of stuff behind it. Databases, how it accesses, how it writes database, your logging, and so on with all of these different properties. Cool. So that is effectively exposing an endpoint, getting that saved into a database with a put. If I go back to the website, the browser, and if I go to this post, if I hit it, it's still returning me blank. Let's go figure out why. Because there's definitely something in the database.
Kuben?
Yes?
It's on the get, we changed to an array
New array
list
list.
instead of getting,
yeah. And you see, going back to that example, if I ran my test, it would have failed and I would never be able to build this. Because I skipped my test when I was showing you now in development, this would never get to production. And somebody might have forgotten it. In this example, I wrote this in, we forgot about it, we go on, write our application, and then we're like, oh, why is this failing? And there we go. That's the reason why. But because of our test, if we ran our test, this would have failed. This would never have got in, would never have been deployed anywhere but you running on your local machine. Because as soon as you put it into, you want to deploy it and the tests will run, this error will come up. So all I have to do to fix it is return a post repository of get find all. So the importance of tests is tests are so important to application development, and this is one of the examples you can see why, because developers can easily go and manipulate stuff while they're developing, and if it's not checked properly, ends up, or if it's not tested properly, can end up in a production environment and end up having a lot more issues when it goes to production. So if you're listing a list of products on a shop that you're selling and suddenly a developer does that, you have a potential of losing sales because somebody went and did this set of code where they replaced it. But if we had the tests, that would have been avoided. So now, if I go and click on this, there's my one result. So now it went and got the result from my database, and it's showing it to me on my screen. Basically, we got something that we can save, and we can access it back. But now, one of the features was we said we can like a post. So we said this ID, we're going to say, okay, cool. We're going to take this ID. The URL was post, the ID that we're going to do, and we're going to say like. And what this is going to do, it's going to find that record with this ID. It's going to say increment that like to 1 and save it. So I hit the get method. It says, oh, your likes are 1. So let me do it again. Now it's 2. Now it's 3. So what is happening is we're using both. We're using the get. We're going to get this data from the database. We're setting that add likes method in our code. If I go back here. So we have the get method controller. We're hitting this endpoint, like the post ID like, fits in the ID in here, goes to the like post. It runs through, actually, let me debug it. Cool. So as you can see, it brought through the ID that we specified. We found that post in the database, which is of this post here. It has the current likes, so it's 3, which is in the browser at the moment. So it has to go to 4. It runs this add like method, which goes in here, runs the ++ and says, okay, I'm incrementing you to 4, as you can see here. And that returns that value, saves it to the database, because now I incremented the object. I didn't save it to the database. All I said is application, this object reference, I've increased the like, and now I'm saying, okay, now that I increased the like, go save it in my database, which is doing here, and it's returning that object back to the screen, and that's why you see the objects go to 4. The likes, number of likes go to 4. Okay, so that's covering practically all of the different methods. And what I'm going to show you now is I have that Angular application that I set up, and I'm going to show you all running that, what you can do with this. So it looks pretty plain now. If you're looking at this, you're saying, oh, it's only JSON. But what can you do with this? What can you do with this data and functionality? And what you can do with it is pretty powerful. And I'm going to run that Angular application. I've already running it. So let me just double check. Okay. This is an error that all of y'all will come across. When y'all start this example, all of y'all will get this exact error. Spring Boot's got something built into it for security that allows, when you deploy an application and you're trying to access it from a browser via URL that's not itself localhost 8080, you can see that this is localhost 4200. It says, sorry, you can't run, I can't run you. Sorry, you can't. You have an origin of this URL and I'm blocking you. You haven't told me you can access it. And this is by default. When you include Spring Web into your application, and you can ask the developers that work for me, this problem comes up with every single one of the applications. If you don't cater for a CORS policy that says cross-origin policy, you will actually not be allowed to access this URL, access this API via this URL. But luckily, Spring Boot says, hey, I can make that easy for you. So if you go back to your controller and you go, you can go into your code on your controller that you want it to be cross-origin. You can do this on a global level, but for this example, I'm going to show you on this just this level here. So you can say, I want to say, I want to allow cross origin for this URL. So you say at cross origin. My origins is localhost 4200, which I want to access. As you can see here, this is the URL you want to access. And give it a max age of 3600, which just says how long can this connection stay open via this cross origin. So it'll kill the connection if it takes longer than that. If I restart my application now, restarting it, it should implement this code and now allow me from a security perspective to access this code. And again, every one of you, if you're going to build this example, will run into this problem. Everyone runs into this problem, and then they get stuck and it becomes confusing. But it's with Spring Boot, it's very, very simple to make it work. Boom. So now I have access to it. That test message I created with 4 likes is coming up. So this simple API, I mean, we can make this look a lot better, but we can say we want to create a new post, go into create, brings up a subject and a message, which we can enter in here. So I can end the post 2 as a subject, test post message 2, create this, created it, and there's your message here. So this is another post. It's got 0 likes at the moment, and I can go and click the like button and it'll increment the like on the top, as you can see. And if I go to the database and I go look at the database table and refresh this, you'll see it added that new test post message directly from the browser. It's 13 likes at the moment, which is 13. That means if I keep liking these messages and I refresh my page, it's going to show me these likes because it's already going to a database, saving it in the database, returning that value. As you click here, it went to the database, returned, and incremented the count. It's actually happening in the database right now. It's happening through all of those different layers, and all of this functionality is happening with this. So that's how a like button works. This can, in further sessions, we're going to show you much more complicated ways of creating a kind of a like button with events and large data. But for the most basic example, you can go create a website that you can go add these type of posts and have it likable immediately. So you can have an open website with this little code. Obviously, you can go and format it a bit better. You can have images, you can go create users. And on future sessions, what we're going to do is build on this example. We're going to build on user security, so you log in before you see posts. Security on posts that only your friends, so you can link to people and add logic into that where you only see the posts that are applicable to your friends. So we can build a Facebook-like example with this, and we can build it on until we get to a point that we're happy and everyone understands how this works, because this technology can build as we go on. So in the last hour and a half, hour 50 minutes, we took nothing. We took a browser with a blank application, added 4 basic libraries to it, configured it with minimal amount of code, and had this application that can be built in the front end. So our backend server right now is built, and we can go build an Angular application in further courses that shows you how you can go build this, how you list this on the screen, how do you add likes, how does this logic work, how does it end up calling a service in the background. And you'll be shocked to know when we go into Angular, it follows the same structure of what I built in my Spring project. It has a controller, which they call components. It has a service layer, which they call service, which can access a database layer via the URL. So the only difference within the structure of this application is that it doesn't have a database. It calls an endpoint. So your service, instead of calling a database, calls this, the back-end endpoint, which is this application. So it'll call this code. That's the only major difference. But the structure, you'll have a component folder, which is your web folder with all of your controllers. It's actually in Angular 1, it was called a controller, and you'll have a service level, and that I'll be covering in future talks, in future sessions. Cool. Yeah, what is the time? 10 to 8. I was actually made the session till 8 o'clock, and I opened up the last few minutes just for open discussion. What we'll do is you can put up your hand in the chat, and then we can discuss certain things that you might want to know about and so on for the next, I would say, 20 minutes or so, and then we can call it. I will be sending you all this recording because I've recorded this entire session. I will be sending you all of the links for everything I have, how to set up your MongoDB, how to set up Docker to get that MongoDB set up as well, and how to, I'll write the Angular code into GitHub as well, so you can access that Angular code and you can run the application. You don't have to know how the application Angular works right now. When we do our next sessions and we cover Angular, we get to understand it a little bit better.